below shows the immiscible liquid formed immiscible liquid. So the diagram below shows the immiscible liquid formed by mixing kerosene and kerosene and water. If you are doing this at home, you can mix them in a glass or in a plastic material. If you are doing it in laboratory, in chemistry laboratories, you can use a beaker as a mixing solvent or as a mixing of the solutions that you have. So this is the diagrammatic representation of a laboratory beaker. And then here we have, let's say that this is solvent A and this is solvent B. So this, we call it a beaker. I believe that you know it at your level. And then here we have the solvent A. According to the reasons that I will tell you, because sometimes you can be asked the questions why you mix water and kerosene, why water floats, why kerosene float at the top of water. What does it mean? So and then this is presentations of denser, high denser solvents. I will tell you that the means of less denser, high denser. So this is kerosene. And then this is water. And then this line, this one, this is what we used to call separating layer. Separating layer which separate between the two solvents. So this is kerosene solvents and this is separating layer. And this can be labeled as figure 5.21. So it is showing immiscible liquids. So this figure is showing immiscible liquids. Okay? So with this diagram, diagrammatic representation, we say that we have a beaker, we have a kerosene, it means even if that in this beaker you pour kerosene the first solutions within the beaker, and then the second solutions you pour water, what is going to happen? The kerosenes will be floating above the water, and the water will be at the bottom of 40 of the separating layer with kerosene. So it doesn't mean that we pour the water at first. No. Whether you pour water at first or pour water next after pouring the kerosenes, what is going to happen is mean that the kerosene is going to float in the water regardless of which solution, which solvent has been added at the beginnings of 40 of this experiment. You can buy maybe a quarter liter of kerosene, and also you can take a quarter liter of water and mix them, and then you'll see the separating layer and you'll enjoy chemistry. Chemistry is beautiful, right? Okay, good. So do you have any question up to that moment? I believe you do. But one of the questions that you ask yourself while you are thinking or you're meditating about immiscible liquids, and especially the diagrams in the previous column, is this: why kerosene is floating at the top of 40 of water? And that is a chemistry question. Now, I would like just to answer it for you to understand before we go to the issue of 40, the issue of the other issues, right? So you say that. We say that in chemistry, we say like this one. The question is, how do this is question 3, how do immiscible liquids separate themselves when they are mixed, because the process is not the human beings that separating them, but it's they used to separate themselves, right? The cause, we say that immiscible liquids, right? Immiscible liquids separate themselves depending on the air molar, on the air densities, So the parameter which these immiscible liquids use to separate, that for the one immiscible liquids to be at the top of the other, or the one pure solvents to be at the bottoms of the other, the factor is density. That's the parameter that they use, right? So what does it mean? We say that the less dense pure solvent, right? The less dense pure solvent, let's say, less dense pure solvent floats at the top of the separating layer. The less dense pure solvent, the pure solvent which composing immiscible mixture with the less denser pure solvent which is forming immiscible mixture or immiscible liquids with another high denser solvents is going to float at the top of the separating layer, regardless that you pour it in the beaker or in the mixing equipments or mixing equipment, then the less denser solvents always is going to float at the top, right? So the issue is the densities. So we say that the high dense solvent, okay, high dense solvent will appear below the separating layer. Interesting. So for this, according to this fact, we say that, for example, according to this fact that I've explained about the issue of densities of pure solvent, okay, we say that kerosene, for this case, now we say that kerosene is less dense than water. Less dense than water. That's why appear at the top of separating layer. Okay, interesting. So that's why that kerosene appeared at the top of water. So even all of these examples, you'll find that you have a high denser solvent and a less denser solvent, right? So that's what you have to bear in your mind. Okay, any question concerning about what I've taught you, ask it in the comment section. Don't forget, don't hesitate yourself. Ask many questions as well as you can. Again, another thing which I want just to let you know, I don't know everything. I just know a little about immiscible liquids, but I'll try my level best to teach you what I know concerning about immiscible liquids, so you'll enjoy chemistry. Okay, again, we want to understand about immiscibility. We have against another technology which we call it immiscibility. Say it with me. Immiscibility. Pronounce it again and again and again. Immiscibility. Say immiscibility. So the question what is immiscibility? We have miscibility, the terminology known as miscibility, that is regarding about miscible liquids, but also we have immiscibility. So immiscibility, simply we say that in chemistry, is the property. The property where two substances are not capable of combining to form homogeneous mixture. Immiscibility is a property where two substances, this is the property where two substances or two solvents are not capable of combining